Bismillahirrahmanirrahim. We are going to start question number 3 of exercise 1.4, in which we are given that this side is equal to this side and we have to prove the rest of the two parts. So first of all, we are going to use this equation to develop some more equations which we are going to use in the further two parts. So first of all, writing the same question over here. Okay, this is the question, and now we are going to simplify it further. As we can see that a complex number consists of a real part, this is the real part, and an imaginary part, this is the imaginary part, and this goes for every complex number Zn. Zn means that if it's Z1, then it would be x1 plus y plus iota y1. But the real part and the imaginary part both exist simultaneously in all complex numbers. So there's a real part and an imaginary part for every complex number, and that can also be written as this, in which Rn is this value square root of the real part square plus imaginary part square, and the theta over here can also be written in this way. So now we are going to solve it. This one is just like Z1, it's like Z1. This one is going to be like Z2, Z3, and then dot 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 up to Zn. And now we are going to use all these values, as you can see over here. We are going to use these values and we are going to simplify it further. So now we have Z1 can also be written as R1 into cos theta 1 plus iota sine theta 1 dot. Now Z2 is R2 into the same value with theta 2 over here. So cos theta 2 plus iota sine theta 2. Then the same for Z3. So R3 into cos theta 3 plus iota sine theta 3. Now dot 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 with Rn. So we have Rn into cos theta n plus iota sine theta n is equals to, b a plus b iota. Now while we have written all of this, now we are going to combine all these R1, R2, R3 and up to Rn over here. So R1, R2, R3 dot 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 up to Rn, multiply with all these terms. So we have cos theta 1 plus iota sine theta 1, then into cos theta 2 plus iota sine theta 2 plus cos theta 3 plus iota. Okay, यहाँ पे plus नहीं है. So I have written this step completely over here. All these R terms are multiplied with each other and the rest of all the terms are multiplied with each other. Now we are going to use a formula which I've mentioned over here, which says that cos A, just like cos theta 1 plus iota sine theta 1 into cos B, this theta 2, plus iota sine theta B, which is theta 2 over here. When these two multiply, they give us cos A plus B plus iota sine A plus B. Now we'll get cos theta 1 plus theta 2 plus iota sine theta 1 plus theta 2. But we don't have just theta 1 and theta 2. We have a number of thetas and then up till theta n. So we are going to add all of these thetas together in the next step. As we are going to do it, this will be written as it is R1 dot R2 dot R dot up till Rn these will be written as it is, and then for all these terms we are going to write it as cos theta 1 plus theta 2 plus up till so on till theta n, and plus iota sine, again here it is a plus b only because there were a and b only. Now we have theta 1, theta 2 and up till theta n, so we are going to write all of them here together, theta 1 plus theta 2 plus up till theta n is equals to, another bracket closes over here, and then a plus iota b. Now consider a plus iota b as a complex number z. Now if it is a complex number z, it can also be written as r into cos theta plus iota sine theta, and this r is equal to all of these terms when compared, and this theta is equal to these terms as when compared, and this theta again these terms, so theta is equals to this term and these all terms, and all these thetas added together, and this r is equal to all these r's multiplied together. So we have r equals, we are going to write it over here, this, the r of this term for z equals to a plus iota b. We have r is equals to r1 dot r2 dot r3, and we have theta equals to theta 1 up till rn, theta 1 plus theta 2 plus theta 3 plus up till theta n. So this is the result of all the comparison between these two sides of this equation. Now using these values we are going to solve all of them. Okay, so I'm going to erase all of this. You have to remember this formula to solve this question. Now this is the first part in which we have to prove this side of the equation equal to this side. So to prove it, we are going to take square root on both sides. Why are we going to take square root on both sides? Because once we have taken the square and a and b are the real and imaginary parts, so it becomes this form: real square plus imaginary square in whole square root. So real square plus imaginary square in whole square root. So when we take the square root, we'll get this form and then we can move towards any solution. So here we go, taking square root on both sides. First of all, square root, and then what's inside it? x1 square plus y1 square into x2 square plus y2 square into x3 square plus y3 square, sorry, here, and then up till xn square plus yn square equals to square root of a square plus b square. Now we are going to write these square roots separately on each of the following terms. So we get square root of x1 square plus y1 square multiplied with square root of x2 square plus y2 square into square root of x3 square plus y3 square up till square root of xn square plus yn square is equals to square root of a square plus b square. Now for this square root of a square plus b square, we have named it r, so it is equals to r is equals to, now this one will be called as r1 because it's z1 now, it's z1 equals to x1 plus iota y1, this one is z1, so its magnitude part would be r1. Now this is r1 dot, this one is r2 dot, this one is for r3 dot up till this one is for rn equals r. So we are going to shift it over there, and this statement we have already proven it from here, so this means that we have proved it. Okay, so this is the second part which we have to prove using the statements we have concluded from the question. So now first of all we are going to open the summation. This sign is called summation. This is the initial value and this is the final value. I'm going to repeat. This sign is called summation. This is the initial value. This is the final value. We have to start putting through this value and end up at this one. So we are going to start with r equals to 1. So it is tan inverse y, r is 1, so y1 divided by x1. Now for summation we add a plus sign and then again we write the same term for the second value. So tan inverse y, we are done with 1. Now we'll increase 1 and we'll write 2 by r2 x2 plus tan inverse y3 by x3 up till we have to write it till n. So we are going to write it over here, tan inverse yn over xn equals to tan inverse b by a. Now as we know that theta n equals to tan inverse yn by xn, so we are going to write this term as theta 1 plus, because it is the same as this one, we have just replaced n with 1, so we are going to write 1 over this side also, so it is theta 1. Theta 1, then this term is theta 2 plus this term is theta 3 and plus up to this term is theta n equals to, now we have got tan inverse b by a. B is the imaginary part, a is the real part. So tan inverse imaginary part by real part gives us theta. Now this is again the same statement that we have deduced from the given question. So we have proved it too. Thank you.